Hello, this is Yang Rui. I'm the Technical Director of Telecom Cloud and Core Network product line from ZTE. I'd like to share some of the experiences from the 5G standalone commercial deployment. First case, the 5G standalone network for China Mobile. It is probably going to be the largest 5G SA network globally, according to subscriber capacity. The project started from end of 2019. ZTE has won 30% market share in consumer network and 35% of the business-oriented service network. The consumer's network capacity in phase 1 is 40 million subscribers and 34 Tbps of throughput. That's right, there are 2 5G cores in China Mobile's network, one for consumer-oriented service and one for business-oriented service. These 2 SA cores share the public NR and the same cloud resource pool. Let's look at the network plan. Of course, the whole network is based on SBA, cloud-native architecture, fully virtualized. The control plane is centralized deployed in 8 big regions. ZTE is now delivering in 6 regions of them. The user plane is distributed in provinces, even cities. MAC is planned in business network, together with UPF to support vertical applications. End-to-end network slicing will also be a key to offer industry support in the business-oriented network. User data migration from 4G to 5G is a very important step to launch commercial 5G service. ZTE deployed the converged SDM to cover the 3G, 4G, and all the way to 5G users. And further to that, ZTE's innovative IWF solution has been extremely helpful in the user migration procedure. The IWF connects to 4G HSS and 5G AMF both. It maps 4G authentication into 5G. So to migrate 5G users from 4G network one by one while accessing network. Subscribers can use 5G service without changing the SIM cards and numbers. Don't even have to go to the business hall at all. China Mobile doesn't have to run user data migration or cut-over operation. No need to upgrade the BSS or current 4G HSS. No need to worry about cross-vendor cut-over. IWF solution is also being applied in other projects abroad. This is one of the very important experiences we'd like to share today. China Telecom, which is the largest fixed-line operator in China, also a huge FMC carrier. China Telecom and China Unicom will have a shared NR, but separated core network. In China Telecom's 5G standalone deployment, there is one 5GC for both consumer and industrial applications. And there is one separated 5GC as IoT base. ZTE has won 45% of market share in the 5GC and half of the IoT base. China Telecom is not planning the network as centralized pool, but deployed in each provinces. There are 31 provinces in China. The networking is a lot more complicated. That's why the enhanced SBA architecture defined in 3GPP Release 16 has been adopted. SCP, the service communication proxy, is deployed for charging in roaming scenarios to simplify the network, which is similar to DRA in EPC network. The user plane and MAC are distributed deployed for both networks. With China Unicom, ZTE's common core solution has won 27% of market share in 6 big regions of control plane and 14 provinces of user plane. China Unicom also planned 2 separated 5GC for consumer service and industrial-oriented service. The control plane is centralized deployed in regions and UPF will be distributed in city level. MEC is planned in the business-oriented network. The delivery of these projects are still ongoing, and ZTE has learned a lot during the project's rolling out. The following informations are the key technologies we'd like to take as fundamental to facilitate commercial 5G SA service launch at step 1. 5GC must be fully virtualized, cloud-native, service-based architecture. That's the basis. Instead of introducing an extra new network, making the network more cross-connected and complicated, the 5GC should be able to cover 3G, 4G access as well. So the target network is no longer multiple chimneys, but one core for all. A deep-level converged core network is able to offer converged user data management, converged policy management, and converged control user plane for any generations of the technology. Besides simplifying the network, the inter-system handover can be greatly reduced, like 4G, 5G handover, so to improve the network KPI and optimize user experience. 5G technology is the best accelerant for industry digital transformation. Also has brought in the new market opportunities for telco operators. End-to-end network slicing is probably one of the key approaches to monetize 5G network and resource. Different slicing strategies offer different SLA, including different security level. A simple logical slicing can offer verticals or private network owners a simple solution with lowest cost. The NR, control plane, user plane, everything is shared from the public network, and no O&M work required on the premise. Or apply the hybrid slicing for higher SLA standard customers. A typical scenario is to logically share the NR and the control plane from the public network, but to deploy the dedicated UPF and MEC on the premise, so to reduce the network latency and guarantee a higher level of security. Or slice everything physically, including NR, core, and the MEC, which usually lead to a top level of the system security and isolation. In case like this, a compact 5GC can be applied to cut down the cost and save the equipment room. We just talked about how to slice the network for verticals or private networks. In many cases, it's required to install equipment on the premise, outside of operator's professional equipment room. Actually, the requirements for edge deployment is so diversified. Sometimes there's no extra room for new servers at all, and sometimes the rack is shallower than regular size, and sometimes huge bandwidth is required, but only very limited space and power supply is offered. ZTE's solution is to make the portfolio as flexible as possible to fit in. MEC and the UPF can be installed as embedded module inside of BBU or OLT, so no extra room will be required. The edge size server has 450 millimeter depth, smaller than regular cards. Compact product is available, which means the equipment is designed with internal switching module and it supports vFirewall, NAT, so only one box will be required and support one key installation and fast service online. On-site O&M is barely needed. GPU FPGA Smart NIC are applied in case of high standard requirements for computing and extreme large bandwidth data forwarding. MEC is the point to show full benefits of 5G technology. It boosts the whole ecosystem, including telco operators and industry. The idea of MEC is to help operators to be more supportive and to be more competitive on the market, and to be a connecting hub for IT and CT industry. On top of a comprehensive hardware family, as we just introduced, ZTE is launching the Edge Cloud, supporting both OpenStack and Kubernetes. Operators may monetize the infrastructure as IaaS or PaaS. The third-party applications can choose the platform flexible as required. Telco network capabilities are exposed to verticals with APIs, like TCPO, traffic offloading, RNS, location-based service, QoS management, etc. ZTE MEC provides more than 100 network capability APIs to help operators to open up, to build a great environment for the whole ecosystem together. That's all for my presentation. Hopefully, our experience is helpful to you too. Thanks for watching.